Today we will discuss our new topic, that is chemical bonding. Now we will start off this topic with the introduction. As we know that pre-existence of the atoms generally are not possible. For example, pre-existence of hydrogen atom is not possible, but existence of molecules are possible. For example, H2, that is called molecule, is possible. But it is not always true, since some elements exist in the atomic form, like helium, which exists in the atomic form and never exist in the He2 form. So, in this topic, we will discuss which types of elements exist in the atomic form and which types of elements exist in the molecular form or maybe compound form, and how some elements exist in atomic form and some elements exist in the molecular form. When element exists in the molecular form, then the force which holds the atom together within a molecule is called a chemical bond. For example, in H2O, here is the three atoms. Two atoms of the hydrogen and one atom of the oxygen. In the H2O molecule, all three atoms combine together by a force. That force is called chemical bond. Similarly, in CO2, there are three atoms, but all three atoms are combined by a force that is called chemical. In NaCl, two species combine together by a force that is called chemical bond. When we discuss these examples, then a number of questions now arises. First question is, why do atoms combine? Why do atoms combine? And second question is, why are only certain combinations are possible? All combinations are not possible. For example, exist as H2 molecule in the form of H3. Similarly, nitrogen exists in N2 form, never exists in N3 form. And the third question is that why do atoms combine and why do some atoms are not combined? For example, H2 are combined but helium are not combined. The next fourth question is, why do molecules have definite shape? For example, CO2 is linear but H2O is V-shaped. Ammonia, that is NH3, is pyramidal. For solving out of these problems, time to time, different scientists have been proposed their views. Now we will discuss some views. Time to time, following theories are proposed for solving the questions. The first theory is given by the Louis Cossel, and second theory that is given by Gillespie and Lyon, and that is called BSEPR theory. Its full form is balance cell electron pair repulsion. And the third theory that is called BBT, balance bond theory. And fourth theory that is called molecular orbital theory, MOT. Now we will discuss one by one these theories and start from Louis Cossel approach. Lewis-Corsell approach completely depends upon valence electron. That's why it is called electronic theory. Lewis and Corsell study the electronic configuration of the noble gases, and on the basis of the electronic configuration of noble gases, it is clear that they are chemically inactive because they have 8 electrons in their outermost orbit, except in case of helium, which has 2 electrons. Hence, it was suggested that they have stable electronic configuration. In case of all other elements, the number of electrons in their outermost shell is less than 8, and hence they are chemically reactive. This leads to the following conclusion: the atoms of different elements combine with each other in order to complete their respective octet, that is, 8 electrons in their outermost shell, or duplet, that is, outermost shell having 2 electrons. In case of hydrogen, lithium, and beryllium, to attain stable nearest noble gas configuration. So, Lewis-Corsell theory completely depends upon the electronic and the electronic configuration of noble gases. For example, hydrogen, its atomic number is 1, that is 1 is 1. It tends to stabilize like helium, that is 1 is 2. Similarly, sodium, that is 11, its electronic configuration is 2, 8, 1, or 1s2, 2s2, 2p6, 3s1. In the outermost shell of sodium contain 1 electron, and neon, that is 10, 2, 8. Sodium have a tendency of losing 1 electrons. So losing 1 electrons, it can 8 electrons in their outermost shell like a neon. So Lewis-Corsell approach completely depends upon the electronic configuration of noble gases. Therefore, that is concept is also called octet rule. And according to Lewis-Corsell, each element tries to complete their octet. Now we will some other examples. For example, calcium, it is 2, 8, 8, 2. For complete octet, lose these 2 electrons. Magnesium, 12, that is 2, 8, 2, which again lose 2 electrons. And next is potassium, that is 2, 8, 8, 1, which again lose this 1 electron. So Lewis-Corsell approach completely work the valence electron and complete the octet. Now, after the Lewis-Corsell approaches, some questions again arises how atoms are combined together and how it can be possible that one atom combine to another atom. Now, how two atoms combine together? The sorting of this problem following theories are proposed, but discussing any theories, discuss some point. First is when atoms combine together in order to complete their respective octet so as to acquire the stable inertial configuration, this can occur into two ways. First is by complete transfer of electrons from one atom to another atom. This process is called electrovalency. The chemical bond formed is termed as electrovalent bond or ionic bond. For example, in NaCl, there is the sodium 11, that is 281. By the losing of one electron, sodium have electronic configuration 2,8 by the one positive charge. Similarly, Cl, that is 17, 2, 8, 7. by gaining one electron, Cl negative 2, 8, 8. In this, sodium have 8 electrons in their valence shell. Similarly, Cl also have 8 electrons in their valence shell. In this process, both atoms, sodium and chlorine, complete their octet, but the complete transfer or gaining of the electrons, in this case, sodium complete transfer of its one electron and Cl completely gain of the electrons which is transferred by this sodium. This types of tendency is called electron formation tendency, and the charge which is obtained after gaining or losing electrons is termed as electrovalency. Now second way is by sharing of electrons. By sharing of electrons, this can occur into two ways. First is when the shared electrons are contributed by the two combining atoms equally, the bond formed is called covalent bond. For example, H2. In the H2, shared electrons comes from both hydrogen. Therefore, it is the case of equal sharing. And the second type is when shared electrons are contributed entirely by one of the atoms but shared by both. The bond formed is known as a coordinate bond. It is also called dative bond. For example, when NH3 comes with the contact of H plus, then the resulting species obtained is